So let's start. Now, okay, so we were doing law of chemical combination. Okay, law of chemical combination. So we have done, well, there are two laws we have done. One is law of constant proportion. This one we have done already. Second was law of multiple proportion. Okay, so there is third law that you have to do. Law of reciprocal proportion. Okay, these are given in NCRT. Okay, these are given in NCRT. So let's do this one, that third law, law of reciprocal proportion. Okay, so there is nothing about the reciprocal. Okay, it is just that because it was given in 1792, maybe 93, I don't know. So that was the starting of chemistry. At that time, there is no knowledge of mole concept or all these things, chemical reactions. Okay, now in this law, it is written that okay, there's a definition, but that is very complex. Okay, it doesn't make any sense. So suppose here I write, okay, suppose this is A reacts with B, sorry, A reacts with B in a simple whole number ratio. Okay, B reacts with C in a simple whole number ratio. Okay, then C reacts with A in a simple whole number ratio. Okay, this is the basic meaning of that law of reciprocal proportion. Okay, so that is the basic meaning. If A is reacting with B in a simple whole number ratio means what? Okay, every time, yesterday also, you will see that there is in the definition in the NCRT, simple whole number ratio is important. Simple whole number ratio means atom can exist only as simple whole number 1, 2, 3, 4. Okay, there cannot be half nitrogen atom or half or 3 by 2 oxygen atom. That is not possible at all. Okay, simple whole number ratio means element will exist as simple whole number, atom will exist as simple whole number. Now what does this mean? Suppose you take any three element, we take phosphorus, oxygen and hydrogen, suppose we take. So suppose this is phosphorus and oxygen, they react and they give P2O3. Okay, so that is your simple whole number ratio, 2 is to 3. 2 is a whole number, 3 is a whole number. Oxygen and hydrogen, they react and they give H2O. So that is also your simple whole number. Okay. Then this is, suppose you can take it as A, B, C. Now A and C will react. So A and C will react means phosphorus and hydrogen. So phosphorus and hydrogen will react to give pH3. So again that is a simple whole number. Okay, that is a simple whole number. So that is your 2 is to 3, 2 is to 1. So that is your 1 is to 3. Okay. So that is basically this means. Okay, it doesn't make any sense for you because you have learned the valency concept. At that time, there was no valency concept in 1792. There was no valency concept. So they understood valency as this one, as the number of atoms, basically. So that was the concept there. Okay, so everything is in simple whole number. So that is your law of reciprocal proportion. Okay, this one. So but you can understand that one, there are numericals based on that. Okay, you can check out whether it is coming as whole number or not. That is a basic thing. Okay, this one. Okay, so this is one of the law. Then okay, yes. Okay, that is given in NCRT. Okay, everybody is using laptop or you are using mobile. If even if okay, whether you are using a laptop or a mobile, power mode. Okay, so my suggestion is that you just download the NCRT. Okay, because if you are reading on laptop, that is easier. You don't have to carry everything. So have you understood this one? Now let's take another example of this concept. Suppose it is, let's take carbon and take oxygen. What we take? Carbon, oxygen, hydrogen. That will be simpler for you. Okay. So what happened? What happened? Okay. So carbon and oxygen, they reacts and form carbon dioxide. Okay, we are taking carbon dioxide here because normally the valency of carbon is 4. Okay, oxygen and hydrogen, so that is your H2O. Then carbon and hydrogen will give CH4. Okay, here the ratio is 1 is to 2. What happened? Okay, so here the ratio is 1 is to 2. Here the ratio is 2 is to 1. Here the ratio is 1 is to 4. So that is your simple whole number ratio. Okay, this one. So that is basically the thing which is required here. Okay, simple whole number ratio. But it is the valency which is the basic thing. Okay, carbon has valency of 4, oxygen has valency of 2, hydrogen has valency of 2, 1, and oxygen valency of 2. So that is basically the valency thing. But now we know it is valency, though, so that is the obsolete, outdated means law. So we don't study that much. So that is okay there. You can do their numericals which are given. Okay. They can come in exam. I'm not saying they are outdated so they will not come. They will come in an exam, but practical application is zero for them now. Means whatever we are doing, okay, there is a practical application, so that is okay. So we are just ending it here. Okay, same way there is this Gay-Lussac law and or Avogadro law, okay, that you can read from the NCRT. They are always based on the valencies out there, all the mole concept. Okay, just once read it and then you can do it on your own. Okay, another thing I want to, okay, this uh, tell you that the average mass, okay, average mass, average mass of mixture, average mass of mixture. Now average mass of mixture means that suppose there are, okay, so let's take an example of chlorine atomic weight. Now what is the weight of chlorine? Chlorine 1 mole weight is your 35.5 gram. Okay, 35.5 gram. So chlorine we write, okay, atomic number of chlorine is 17. Atomic number of chlorine means 17. It means, what does it mean? It means 17 protons. 17 protons are there. So how many neutrons? How many neutrons are there? Prince. How many neutrons chlorine have? Prince, are you there? Princey, where are you? Prince is gone. Okay. Prince is not here. Where is Prince? Playing PUBG. Okay. So how many neutrons? Huh? Are you there? Uh, so 17 protons are there. Okay. 17 protons and neutrons are 18. Okay. 18. How many neutrons? So there are 18 neutrons and 0. So 17 plus 18, how much it is? 35. Okay, but it is 35.5. So why it is 35.5? Because if it is 35.5, there should be 18.5 neutrons. Then it would be, 35. If we add 17 and 18.5, then it is 35.5. Yeah, half neutron is not possible. Okay, half neutron is not possible. So what happens that this doesn't make any sense. So why it is 35.5? Due to the average mass of the mixture. Now what is average mass? Okay, so when, oh sorry, when there are isotopes of atom, okay, isotopes, you know what are isotopes? Prince, different different mass number. Okay, so when we have isotopes and there are certain percentage of that isotope, okay, suppose this is your isotope and that, okay, two isotopes have considerable abundance. Okay, two isotopes have, okay, considerable abundance. Abundance means they are present in certain quantity. Abundance. Then we take average mass. Average mass. Okay. So abundance of chlorine 35. Okay, I really don't know what is the chlorine. So there are two isotopes of chlorine. Two isotopes of chlorine. Okay. One is your chlorine 35 and another is your chlorine 37. Okay. So in chlorine 35, okay, sorry. In chlorine 35, okay, 35 means there are how many how many neutrons? 18 neutrons. So 17 plus 18, 35. 17 protons and 18 neutrons. Now in chlorine, wait, 1 minute. Oh, sorry. Uh, okay, this one. It is visible to you. Okay. And chlorine 37. Okay, so there are 70 protons and 20 neutrons there. Okay, so these are isotopes. So basically isotopes have same protons but different number of neutrons, so that makes the isotope. Which element highest number of isotopes? That is something in maybe thorium or uranium, maybe. I don't remember right now, and that is very difficult to answer, highest number of isotopes. But that is your F block, means which are inner transition elements, radioactive elements have highest number. So no, average mass I will teach you this. Huh? Hello. No, it is there in your mole concept. It's an NCRT there. So we take the average mass. Now let me search what is the abundance there. Okay, 1 minute. Okay, now you can see here. Can you see the this chlorine 35 is 75.77%. Chlorine 37 is 24.23. Okay, can you see this one? Okay, there is another isotope is chlorine 36. Okay, so so here we take chlorine 35 as 75%, 75.77, and it is your 24.23. Okay, so chlorine 35, its abundance means percentage. Chlorine 35 percentage is your 75.77 percentage, and chlorine 37 is your 24.23. अभी क्लास ले रहा हूँ अभी. हाँ. So it is 24.23%. Okay, this one. That is called chlorine 36, but percentage is very less, so we don't consider it. So that is called as abundance. Okay, this is called as abundance. So what is the average mass? How to calculate the average mass? Average mass of chlorine. So average mass of chlorine is equal to chlorine 35 means 35 gram into its abundance 75.77. Okay, plus chlorine 37 into its abundance 24.23 divided by total abundance, that is your 100%. Okay, this is the abundance. So this is your abundance which is there. So 35, 37 and 100. So whatever we are getting, it is around approximately 35.5 gram. So that is called as average mass. Are you getting this one, everybody? Okay, this clear. Oh, teeth root surface. Okay, see. Okay, now let's, so that is your this one. So that is your percentage abundance. Similarly, there are various elements with the atomic number, oh, sorry, mass number. 1 minute. Okay, this is mm, yes, this is, so that is your average one. Okay. Okay, so this is your, so this is a basic simple concept. So now so basically what we have to do is you have to find the mass, then the percentage abundance and this one. So here the average mass, okay, average mass is written as m1 n1 plus m2 n2 divided by n1 plus n2. So this is your average mass. So this is your average mass for finding the, you know, mass of the atom if the isotopes are there. Okay, and this is the general thing about the average mass. So this is your n1 is the moles of, okay, first atom or molecule. Okay, then it is m1 mole of first atom, or so that is our mass, sorry, it is the mass of first atom or molecule. Okay, this one. Then similarly m2 and 2, so n2 is the moles of second atom or molecule, and m2 is the mass of second atom or molecule. So this is the thing. Okay, this is the, so we will do a numerical based on this. Okay, so it is important to, so this comes in the chemical equation. Okay, this will come as in the chemical equation. What happens? Sorry. Uh, okay, so this is this. So this is your M1 or you can write anything about. So this is your first mass into number and then okay this one. Now let's do some numerical. Okay. Okay, let's do one numerical on this. N2O4 dissociates into 2NO2. Three laws there is Gay-Lussac law, Avogadro law, and all that. But you can read it from NCRT. These are very simple laws. Uh, yeah, three, but these three also you can read from NCRT. They are very easy. Law of constant, multiple, but just so that you don't, because their definition is very confusing. That's why. Even if you are not getting Gay-Lussac, and then you can, we can, I will teach you. No problem in that. So N2O4 gives NO2. Okay, 2NO2. Okay. Suppose I took initially there are, okay, there is 1 mole of N2O4 and only 25% of N2O4 dissociates. Okay, then A, how many moles of NO2 formed, and B, what is the average mass of mixture of NO2 and N2O4. So this is your question. Okay, this is the question. Okay, are you getting the question? Everybody, do you understand the question? Okay. So okay, take 1-2 minutes and then solve it. now I am solving it. Okay, now the first part. Okay, first part you see that we have done in percentage yield. Okay, this part is in percentage yield. So let's solve the first part. Okay, here now see N2O4. Okay, N2O4 dissociates into 2NO. So there is 1 mole of it. Out of 1, how many are dissociating? 25%. So out of 1, 0.25 will react, will dissociate, and 0.75 will not dissociate. That we have done, isn't it, earlier? Now, yes, all of you can remember that. Okay, or you can see the video, it's video there. Now, out of this 0.25, sorry, out of 1.25 are reacting. Now here in the main equation 1 is giving 2, so 0.25 will give how much? Double. All of you have, okay, so that will be zero point 0.5 of NO2. Okay, so first answer A is, for A answer is your zero point 0.5 moles of NO2. Okay, this one. Now if you see average mass, so what is the average mass? We have to calculate average mass. Now how many of N2O4 are remaining? 0.75 are remaining in the mixture. Okay, which are there, they have not reacted, so they will remain as N2O4. These 0.25 has reacted, means dissociated, so they are converting to NO2, so their existence will vanish, they will not exist as N2O4. So don't consider this, okay, because they have reacted, so they have converted to your this. Okay, or whatever. So that is your NO2. So in average mass, so in B, so average mass is your, what is the formula? N1 M1 plus N2 M2 upon N1 plus N2. So that is your average mass. So here let's take N1 is the moles of N1. Let's take N1 as N2O4 and N2 as NO2. So we can calculate it easily. So N1 is your 0.75 moles of N2O4, because that is 0.75. Okay, what is the mass of N2O4? So mass of N2O4 you can calculate 28 plus 64. Okay, so 8 and 4, 12 to 6, that is your 92. Okay, 92. So that is your first N1 M1 plus 0.5, that is your 0.5. Okay, what is the mass of NO2? 14 plus, okay, so that is half of that one, 46 obviously, because that is half. So 46 divided by N1 plus N2 means 0.75 plus zero point 0.5, that is your N1 plus N2. So here it is 0.75 and zero point 0.5. So 0.75 and zero point 0.5 will be 1.25. Okay, so that is your average mass. Okay, now you can calculate it, and this will give you. So what is the answer? Anybody? 73.6 gram. Okay, this one. So this is the answer. This is how we calculate the average mass of the mixture. If it is a mixture, then we calculate its average mass like that. Okay, All of you are getting any doubt? Okay. So here officially I am ending the mole concept. That is your end of mole concept. Okay, but remember, mole concept can cover whole of the chemistry, but we can't read all of the chemistry in one chapter. So whatever is required to study various chapters that I taught you. Huh? Atomic structure. We will study atomic structure, structure of the atom. Okay. After that, we will study periodic property. After that, we will study this chemical bonding. Okay. Then we can study gaseous state. Atomic structure. How much time? So it will take around 6 7 weeks. 6 classes, 7 classes. Week or so. Okay, so that is the end of it. So let's do some question, revision question, so that you can refresh your concepts. Okay, let's take. Okay, I'm giving you some of the question from N Avasti. Okay, questions from N Avasti. That is a numerical book. Okay, if you have, that's okay. No problem in that. So let's take one of the question. Okay. So two elements are there, X and Y. Okay, let's take the question. Right. X atomic mass, X element is there, some element X. Atomic weight is 75 gram. Okay. Y element, atomic weight 16 gram. Okay, this one. What is the compound? Having 75.8% mass of X. And there are options also. So first option is your XY, second option is your X2Y, third option is your X2Y3, and D is the option is your okay X2Y2, X2Y2. So these are the options. Okay, try to solve this one. Try to solve it. Okay, everybody is getting the answer. Aparajita. Okay. Prince Patel. Aditya Choksi. Okay. Anybody wants me to solve it? Okay. Now you see. Okay, so they have told you the answer. So now it is uh, not a question anymore. But you see that 75 and 16. Okay, out of these, you have to tell which one will give 75% mass of the X. Okay, out of total. So either you can solve from the options or you can just directly solve it. Okay. So suppose if I am solving from the option X and Y. So X is how much? So there is 1X, 1Y, 2X, 1Y, 2X, 3Y, and 2X and 2Y. Okay. So now let's assume that X and Y we are taking. So X is 75. Uh, sorry, X is 75 and divided by total mass 75 plus 16. Okay, into 100 and it should be 75.8. Okay, are you getting 75.8 from this? Okay, no, because 75.8 you need around something 90. Okay, so that is not exactly coming, so that will not come as 75%, so this is not equal. Then you take x2y. Okay, then you take x2 3y. So x2 3y I'm solving because they gave you the answer, all of them. So x2 is how much? 75 into 2. Okay, 75 into 2 is your x2 plus, sorry, so divided by total mass. So let's take total mass. It will be 75 into 2 plus y is 3, so 16 into 3. So that is your, this calculation into 100 will give you the percentage. So 75 into 2 will be 150 divided by 150 plus 48. So that will be 150 plus 8 and 198 approximately. So you can calculate, yeah. So, so you can calculate it and then can get the answer. So from the option you can, so that is a very easy problem. Let's take another problem. Let's take one of the problem. Molarity and molality of, where is the problem, of aqueous solution is 9 and 10. Of aqueous solution is 9 and 10. Okay. Then mass, atomic, not atomic, okay, molecular mass of solvent is 50. What is density of solution? What is density of solution? Okay, so sorry, it is your molar mass of solute they have given. Molar mass of solute, that is 50 gram. So take it as solute, okay, not as solvent. Okay, now see that 9 moles are dissolved in 1000 ml. That is your molarity is equal to 9, 1000 ml. Okay. Now same solution. This is same solution. Okay, this one. Now same solution has 10 moles in 1000 gram. Okay, 10 mole in 1000 gram. So one thing that's aqueous solution. So that is your aqueous solution. Okay. Aqueous solution means water as a solvent. Okay. So the solvent is water. Its molality is 10. Solvent is water. Okay, solvent is water. So 1000 gram is there. Okay. So this 1000 ml. Okay. So this 1000 ml has 9 moles. Same solution we can take as a molality. So 10,000 gram in it is here 10 moles are there for molality. Okay, are you getting? Now what is density? Density is your weight of solution divided by volume of solution. Okay, weight of solution divided by the volume of solution. So volume solution is 1000 ml. Okay. Now what is weight of solution that you have to tell? Weight of solution. So weight of solution is your weight of solvent means water plus weight of solute. Okay, this one. So density is your weight of water plus weight of solute divided by your 1000 ml. In 1000 ml, what is this? So in 1000 ml, okay, if we talk about the this 9 moles, okay, so in 1000 gram there are 10 moles of it. So 1000 gram means we calculate, so that will be 1000 into 18. Okay, so that will be, sorry, 1000 is your 1000, sorry, 1000 gram is your water. So 1000 gram water plus 50, okay, 10 moles are there for solute. So 10 into 50, 500. It's coming as 1.5. 1.5 is not in the option. Answer is 1.35. uh, I did something wrong. What I did wrong? Let me read the question. Nine balls are there. What happened? I'm doing some mistake. The balls Okay, so I might be doing mistake. I don't know what mistake I'm making. Okay, so we will do it later. I'm making some mistake there. I don't know. Okay, it's not coming in my mind what I am doing wrong. Okay, so we will do it later at some maybe on Monday. On Monday, okay, we will do the one concept. Okay, let's leave that one. No, the solution is 9 molar. You can't take 1 molar solution. I will solve it and then I will paste it on the WhatsApp WhatsApp group. Or tomorrow is Saturday, so tomorrow is Saturday. Tomorrow is not there the class. So how do you give tests? Do you give test of physics and maths? With normally do you give some test? So have you given any test till now? So you're not okay. Okay. So please, give some tests. So that how will you give test? Because online it is online, and that's very difficult to take the tests. Okay, nevertheless, but you try to solve the questions. Okay, so we have okay, just close the class. Then on Monday we will meet. Okay, so on Monday, in these 2 days, please try to solve all the question of the modules. Okay, what is the module which is given to you? Please solve the question. Okay, so that you can have some idea. Okay, these all these things will be the basic of 11th and 12th chemistry. Okay, so on Monday we will study atomic structure. Okay, then atomic structure is somewhat more theoretical. uh, okay, so you don't have to do many numericals on atomic structure. Okay, numericals are very simple. There are no hard numericals there, so please avoid any misconception that all this chemistry is like that. Only mole concept are too many numericals, and ionic equilibrium there, ionic and chemical. So these two chapters have numericals. Other than that, there are not so many numericals. So atomic structure, then we'll study the chemical bonding. Okay, then sorry, periodic properties and chemical bonding. So periodic properties, chemical bonding, zero numerical because they are from inorganic. So you have to study theory only. Just remember the things and that's it. Okay. So from now onwards, there will be very less numericals and more of theory. So that will be the real chemistry. It's how do we study atoms and all that. Okay, so you can leave the meeting and I will solve that question. Yeah. I will solve what mistake I am making. See that. Okay, so you can leave the meeting. Please try to solve the module question. Okay, your 12th class students have not done that, so their preparation is pathetic. Those who are those who have passed the 12th class almost. Okay, they are going to give the exam this year. So they because they have not done anything, so now they don't know anything also. You can leave the meeting. Okay.